Welcome to Thursday, December 21st, 2023. Your day weather podcast brought to you by Hot Springs County Travel and Tourism, reminding you that as the temperatures start to get colder again and snow moves in at Thermopolis, you can always find yourself in hot water. Well, the emerging storm that we've been watching all week is going to be impacting the region here soon, moving into the Intermountain West and into the high plains eventually. But a lot of question marks remain. I was hoping this morning to tell you that everything lined up and that we really have a very easy forecast now, but it's still remaining elusive. In the meantime, enjoy beautiful sunrises and sunsets like we here have this picture from Robert out of Fountain, Colorado. Been beautiful, just gorgeous. Many of you had mentioned to me yesterday about the lack of wind, and this is what happens when you get into a split flow like this. You don't really have that much wind either. So the very mild weather continues today, continues through tomorrow with above average temperatures, and those high and mid-level clouds coming off the Pacific will continue to move through. Now, rain and snow will be expanding out of California and further eastward and into the southwestern United States today, tomorrow, and into tomorrow night and into early Saturday. We're going to see a push of the moisture come off the west coast finally and push east then northeastward across the area. Snow is going to begin in some areas as early as late Saturday afternoon and evening, especially Saturday night. The timing is still a little bit tricky. More widespread snow chances and much colder temperatures for Christmas Eve, Sunday, and into Christmas Day, Monday. Now, confidence remains elusive, and we'll show you that here in a moment. We still have big differences, mainly a really big difference between the American modeling and the European and the Canadian modeling and the German modeling and other modeling that we look at. There's just a really big discrepancy. And as long as you have that, you always have to realize that 4 out of 5 models might say one thing and one may be the outlier. Sometimes the outlier ends up being the correct model. That's why you end up having low confidence. We're going to have, regardless, we're going to have travel concerns, especially for those states listed there. Other surrounding states will be impacted as well, but those are the 4 states that will probably have the worst driving conditions Sunday and into the day on Monday. The satellite imagery this morning showing that activity with the southern branch of that jet stream coming into the southwestern United States and Texas. Here's the upper level low off the coast of California, continuing to pump rain into the coastal areas of California. Here's the upper level low that's going to come in out of the Gulf of Alaska, merging with this one. Here's another big storm across the Pacific. There's a lot going on across the North Pacific as that Arctic air mass that brought record cold to China. You know that Beijing, China was down to 0 degrees Fahrenheit earlier this week? That cold air now is spreading across the North Pacific, and that's really making for some interesting weather potentially down the road. But let's focus in on the short term. We've got the low here off the California coast, and let's take a look zooming in a little bit. So you can see this swirl up here, just in the northern, far-reaching northern areas of the Gulf of Alaska, near Alaska there, and all the way down here off the coast of Southern California. Now, kind of hard to imagine that this and this are going to come together, but that's exactly, basically, what we're looking at as we go on into Christmas Eve weekend. One reason we may be having problems, and there's a very good likelihood that this is a large region, that when you look at the expanse of the Pacific, and then you realize that the weather balloons that are launched twice a day around the world, and this is where they're launched from, around the world twice a day. Weather balloons are still the number one best way to sense the atmosphere, to measure it and get a good idea of the entire structure of the atmosphere from the ground all the way up to the stratosphere. So every blue dot, those balloons go up twice a day, or they're supposed to. Sometimes they don't go up, but most of the time, these are the areas. But notice the vast expanse of Earth where we have very few radiosondes or weather balloons that go up twice a day. And for the western United States, this is a big problem because look at the western Pacific, look at the eastern Pacific. These are island locations where radiosondes may go up twice a day, sometimes not all, but there's a large data gap. So when the storms are out here in the Pacific, we're not able to really measure them until they get closer. And when they get closer, and when these storms move into, we'll call it the grid of where the radiosondes are sensing the atmosphere, then we measure them better, and then the models handle them better. And that's one handicap in weather forecasting in the western United States, is this gap right here. Storms really are not accurately measured until they get into the coastal areas or get closer. Now you might say, well, we got all these satellites, we have all this technology. We do, but satellites still do not have the power to go from the top of the stratosphere to the bottom, the surface, and accurately measure everything: humidity, wind, pressure, all of those things. Satellites help fill the gaps, but they're not the best thing. Aircraft reports fill the gaps, but aircraft fly at, as you know, one altitude as they cross the Pacific. So you're not getting all of the altitudes from the ground up to the stratosphere. So we're now looking at this system getting closer to the radiosonde grid, this one as well. So we're hoping that this will lead to better forecasts down the road. So here we are with the two systems, and you can see them starting to merge right here. As they start to come together and coalesce, we still have what we showed you yesterday. The two systems, with the potential of that system going southeast, that one going northeast, but part of that system that's up north there is going to still want to translate eastward or take part of that energy with it eastward. But most of the solutions that we're looking at is for number 3, so basically 1 + 2 = 3, and for that low to be more over Colorado by late Saturday night and into Sunday morning. And then this is what you're basically seeing. Take a look at the European model. By Sunday morning, we've got a closed low near Evanston and Salt Lake City there, and it's going to want to translate going this way. And here's what's left of that low that was up here. They separate and become two separate streams. And if that happens, then you get a more organized storm with the counterclockwise rotation bringing upslope. Also, the Gulf of Mexico is open for humidity to increase and get drawn into the storm. That's why I always talk about when you get a low that's in the Four Corners going across Colorado into southwest Kansas, that brings upslope into the east front range areas of the Rockies and the adjacent high plains. It brings upslope winds, which help create clouds and precipitation, and Gulf of Mexico moisture on the plains gets drawn in. So that's a recipe for a pretty strong storm. That's the European model, that's the Canadian model. There's differences here in strength and intensity, but they're very, very similar between the Canadian and the European. So let's look at the American model. Well, see how it's stretched out? The American model really, really wants to keep these two systems connected energy-wise. So what happens is you do not have the upslope. See this? The curvature of the flow stretches out the low. You still get weather with it, but you don't organize the moisture. You don't have that upslope component. So this is unfortunately an either-or scenario, as we'll show you here in a moment. So this is the snowfall forecast. Don't pay close attention to those numbers you see yet. Maybe tomorrow we can, but this is for display purposes only. Don't look at that number where you live and say that's what you're going to get. Models are tools, they're not reality. But this is a good way to graphically show you where we think the heavier snow could fall in these different scenarios. So the European model is showing a significant snow event for Nebraska, South Dakota, Wyoming, parts of Colorado, even southern Montana, getting into North Dakota, and maybe even northwest areas of Kansas, going all the way back into the Four Corners area in the mountains of Colorado. That's the European model. The Canadian model, look how similar they are, is even more robust with the snowfall. And it actually takes the snowfall, heavier snowfall further west into southwestern Wyoming, into maybe even northeastern Utah there. But they're saying something very similar. But there are some significant differences there depending on where you live. So let's take a look now at the GFS, or the American model, and you'll see a huge difference. A huge difference. The storm can't get organized, you don't get the upslope, and you have what we basically call an open wave comes through. It will snow and it will get a lot colder, but as you can just tell by looking at the graphics here, there's a really huge difference between the solutions. Could the solutions be a combination of all three models? Yes. That sometimes happens, and that's sometimes a way to forecast is to kind of merge the solutions and not go with just one, that might be the right way to go here. But we still have this big discrepancy, and this is really large because the travel impacts here and here are certainly much more severe than this. And when you're out traveling, Christmas Eve, Christmas Day, or the day before, the day after, this really weighs heavy on your decisions, right? If you want to go with the precautionary principle, you'll want to go with the European and the Canadian model. And if you're traveling, hope for this one. Hopefully tomorrow will bring more clarity. That's the same thing we told you yesterday, but hopefully as we get closer, we'll be able to get into more details and be more specific. Have yourself a good Thursday. We'll see you tomorrow.